My name is Jessica McWilliams. I'm a mechanical engineering PhD student at Penn. I always enjoyed solving puzzles as a kid, especially logic puzzles. I can remember my grandfather would always ask me a logic puzzle and I would just kind of figure it out and think through it, and that was just really fun. I never really thought that that was an academic skill. I just thought it was something fun to do, little riddles and things like that. But then when I got to algebra, I realized that it was actually kind of similar to the logic puzzles that I would do as a kid. This software is called Interactive Robogami. In the center, we have a design space where I'm going to build a robot just using my mouse. And I have physical parts I can choose from, and as you can see, if I don't like the way those parts are shaped, I can change it really easily by scaling different panels. I can also add different peripheral parts so that I can make my robot look however I want. In this case, I'm going to make it look a little bit like a house. The same lines of reasoning kind of applied to it. And so I think that's really when my love for math started to grow, is when I was able to correlate the two. And then as I progressed into higher levels of math, I eventually learned about engineering and realized that it too is basically solving puzzles and figuring out how to get through problems using logic and reasoning. And so now I don't solve the riddles, but I solve engineering problems. So here, I'll add a couple of those on. If you look at the bottom, the system is suggesting different ways the robot can walk, which are called gaits. If I click on one, I can then see an animation. This is telling me how the robot might move after I build it in real life. If I want to look at a different gate, I can do that too. And if you look on the bottom right side of the screen, you can see that there's a graphic of the trajectory of the robot. This tells me how the robot is going to move through space. I can also look at multiple gates put together, and it shows me the trajectory of the sequence in black on the bottom right, and it gives me an animation in the middle. If I don't like the way my robot's moving, I can go back and modify the design. Let's make the wheels a little bit bigger. On the bottom right, the system is telling me how the robot's trajectory is going to change based on the change I made to the design. This is really helpful because I can do it all without having to build this robot. I can check in simulation that the design is exactly what I want before I take time to put all the real parts together. In elementary school, I just really enjoyed learning. I liked pretty much all my classes. I just really enjoyed going to school, and I especially enjoyed my math and science classes. But I also just enjoyed art and being creative and getting to hang out with some friends. Also, if your school has computer science, would highly recommend taking that. Even as a mechanical engineer, you think of mechanical engineers and you think of hardware, but most of what I do is actually programming. We made our robot in the software, but now you can see we have it in real life. This was made using a 3D printer, and we printed out the parts, then folded and snapped them together, added some motors, which the software actually told us how we can 3D print it, and it told us what electronics we need and how to connect them. Finally, the software also gave us code that will allow the robot to move. Here's another robot that we also made using the same software. And this one, I'll show you, it actually does walk. So we can see that using that software, you can make robots that actually move in real life. So I told you that the software tells me what electronic components and connections I need, but let's take a look at actually what goes into this robot. So we can see here we have some batteries, and this is the microcontroller. Here we're using an Arduino Uno. This is basically the brain of the robot. That's where the code gets uploaded. And this microcontroller, you can buy it for about $20, and then you can write your own code for it if you want to start learning about coding. We also have servo motors that help the robot to move. So we need one for each leg. And then, since we want an easy way to turn it on, there's just a switch that I can flip to allow the robot to have the power. So this robot is really low cost, and that's something we focus on in our lab, is using materials that are easy to get, not very expensive. Like I said, this is the most expensive part, and it's about $20. The whole robot is very affordable. Some things that really helped me when I was in elementary school in developing the skills I need as an engineer, definitely just learning about everything. So learning about the world, learning about science, learning about math, learning English. Engineers have to write too. But also just being creative. In my free time was always making different art, whether it was modeling clay or knitting with yarn or just finding random things and putting them together to make something I liked, or folding paper. I just really enjoyed being creative, and I think that creativity is something that you should carry with you, because that can be helpful as an engineer in terms of coming up with new approaches to problems and figuring out how to solve things a different way when the first way you tried might not have worked. Just really building those hands-on skills and also your academic skills in your classes. Something else we look at in our lab is origami. We make robots that are inspired by origami. The cool thing about origami or paper folding is that you can actually store energy in the folds. What I mean by that is that if I press on this, it's actually kind of hard to compress. And when I release it, it springs back to its state. That's because the folds behave like springs. We can model how that behaves and make this cool structure. In this case, it's a head. And it's just paper that's folded back and forth many times, layer by layer, so that when you pull on tendons in it, you can get different kinds of motions. I'm super thankful for the support groups I've had as a woman in engineering. My really supportive mentors, that as one of the only females on our robotics team, they really did encourage me to step up and become team captain, even though it was like a little bit intimidating for me at that time. Since the folds behave as springs, we can actually store energy in those springs and create robots that will jump using origami. Here we have some robots that are folded slightly differently. By making just a small change to the folds, you can get one that jumps really well. I would say that building confidence as a researcher is an ongoing process and something that I'm still learning today. I think almost everyone I know deals with imposter syndrome on some level, and definitely when I was starting out, I was like, I don't know anything about engineering. How can I build this robot? Part of it is just having the willingness to accept that you're going to learn things.